Hi, thanks for joining us for Hybrid Cloud Day. My name is Jesse Dougherty.
And my name is Anthony Liguori.
We're going to talk to you about low latency today.
So Jesse, we both work a lot with customers in the edge, and I think you work a lot more closely with customers around latency, whereas I work with them on compute. Why do customers care about latency at the edge? And for end users, like, why would they even worry about latency?
It's a good question. When you think about it, customers value snappy experiences. They expect something to be immediate when they click on it. When it's slow, it gets frustrating. And so if you think about it, for example, most movies are about 60 frames per second to make them feel realistic to you. Mm-hmm. That's about a 17 millisecond flip between frames. But unfortunately, it takes about 50 milliseconds to get a packet from one side of the states to the other, just because of the speed of light. Like literally the physics of it. You can't go any faster than that with today's technology. So in order to make that experience great, we've got to have data centers, networks, and caching distributed around so that our viewers and customers are much closer to the content so they can get that snappy experience.
So as a user, you can actually tell whether you're seeing content coming from across the country or locally.
You can. If you've ever watched a show and it starts to become pixelated or a little bit jittery, that's likely because it's either coming from far away, or you're going over a network that might be shared with lots of other folks. Like, one important thing here is you need to not only have your source be close to you, you have to be accessing it over a reliable network. And that's why critical to any one of these experiences is having for us, a global backbone, building out a network that spans everything.
So all of our locations, that connectivity, like, we own, that's not the internet?
That's right. Well, in a way it is the internet, but it's not the internet. It's our version of it. We have built out a backbone that connects almost every city, over 440 locations globally, where we have these points of presence. We've got undersea cables, so picture boats going across the ocean, dropping real physical cable to the bottom of an ocean. We have those under almost every ocean on the planet. But to keep this all running, so picture that, you've got a network that spans the globe, connecting these data centers and ed locations all over the place. But also picture, things are breaking all the time.
Sure.
Right? The classic example we see is a backhoe, right? Someone's digging a hole in the garden and there goes part of the internet. And so what we also have to do to keep that low latency experience going is to pay attention to this thing. Mm-hmm. But think about how big it is. We've got to monitor thousands of links, billions of times a day, to make sure that we are moving traffic in a way that gets that experience to the user in the best possible way.
Oh, that's amazing. So for a lot of users, a lot of customers, when they're interacting with some of their favorite services or companies, they're most likely having a lot of their traffic go through the AWS backbone, right?
That's correct. I mean, when you access probably your favorite media provider, for example, mm-hmm. chances are pretty good you're connecting to your home Wi-Fi, which is connecting to your ISP, which is connecting directly to our backbone.
Wow.
And so the old traditional internet would throw your packets on a shared link with everybody else, and you kind of wander around until you got to the content. That can't work anymore because mm-hmm. when you're using one of these shared links, which is also called transit, mm-hmm. They can become congested when it gets busy. When everyone wants to watch the same show, it can become, you'll get that bad experience. But if the fact that you're connecting directly to our backbone in all these locations means that we can make sure that it is available and has the capacity to give everyone an awesome experience.
That's fantastic. So, like, what's an example of a media customer that's relying on our backbone today?
Well, I'll give you an example. There's this company, Kiswi, who does a live event for customers. So think concert, right? Mm-hmm. You're going to watch a live concert. You buy a ticket and you're going to watch a live concert. And so when the pandemic hit, suddenly demands for live concerts went through the roof, right? But a company like this, it's really difficult to say, well, hey, I have an idea. Why don't I build a global backbone and deploy things in 440 locations to reach my customers? They have viewers in like 190 countries.
Wow.
So to do that, instead, they work with us. They use our services like CloudFront and others in order to really quickly be able to access, to send this content to anyone in the world. But with the added problem that they needed to make sure you had a ticket. right? So it's not just sharing the information. So they needed a service that could connect you globally, but also had some flexibility. So we've got this, not only do we have the content near you, we can also put little bits of code near you. And that code runs, and the customer can write some that will say, hey, I want to make sure you have a ticket. And so that flexibility helped a company like HisWe grow. It's like just a massive ramp when everyone switched modes during the pandemic.
Oh, that's amazing. That's really fantastic. Another use case that's very similar, that's like super exciting to me and is more compute focused, is gaming. And so again, this is something we've seen, with more people working from home and looking for ways to entertain themselves. Like online gaming has just seen an explosion in popularity. And a really great example of a customer here is Riot Games. And so Riot Games is a global producer and distributor of games, including some of the most popular games like League of Legends. In 2020, Riot actually launched Valorant on top of AWS Outposts. And what this allowed them to do is bring compute very, very close to their end users. And so you mentioned earlier that for 60 frames a second, you only have about 15 milliseconds. That's roughly the amount the time your eye can detect a change. And so if you push a button on a controller or hit a key on a keyboard, and you need to perform some compute in response to that, like you're shooting another player or you're performing a movement, there's really no choice. The compute that's processing that has to be close, right? And so with AWS Outposts and local zones, Riot was able to serve their players and make really significant performance improvements in terms of latency. So bringing that compute close to customers, like that's a big deal, and that's part of the story there. But I know another big part was matchmaking and being able to connect clients to the closest possible server. And I think that's something in your space, right, with Global Accelerator?
That's right. Like, as you can see, we've kind of got this set of offerings. We've got our regions, which are spread around. We've got local zones, which are going to be much closer to populations of users. We've got CloudFront, which can put that content even closer to the user, but not gaming signaling, but like the content that you access. We also have one more, which is Global Accelerator, which basically means when you're connecting to one of your customers, like a game player, we make sure that their traffic moves onto our backbone as close to them as possible. So by doing so, they get all of our great capacity, all of our low latency directly to that compute, as opposed to, as I mentioned before, wandering around on transit trying to hope you find your game. It doesn't do that. It will optimize the link directly there. So a combination of that plus Outposts plus CloudFront means that you've got the opportunity to provide that user with like snappy experiences across gameplay, visual, and stuff like matchmaking.
That's amazing. So like in the US, and I think this is true for most countries, the vast majority of the population tends to be around large cities. And when you look at the coverage today that we have in the United States with regions and local zones, I think we've got close to 17 local zones today, along with a handful of regions. And so really, you can get local compute to the vast majority of the population within the US, which means that you can serve all these use cases and cover most people around. So really exciting stuff. Another area that I think latency becomes really interesting, which is kind of on a completely different spectrum, is financial services. And so in the financial services world, particularly with securities trading, that's a space where we were talking milliseconds, right? But that's a space where nanoseconds matter. So not just microseconds, which is an order of magnitude lower than milliseconds, but all the way down to nanoseconds, which is really just crazy low latencies. A great example of this type of customer is NASDAQ. And so NASDAQ last year at reInvent announced a partnership with AWS to bring their security exchanges into the cloud on top of AWS. So this is literally the software and hardware that is trading securities. 20, 30 years ago, this type of work was people standing around with tickets and yelling at each other. These days, though, you've got some of that, but mostly it's very complicated, very, very optimized algorithms that are actually doing these types of security tradings. AWS Outpost allows that all to happen in that center of gravity in northern New Jersey, where all of these different transactions are happening today, where all of these high-frequency traders are located and all of the other customers that are expecting to work with this workload. And so it's super exciting to me how not just are you serving entertainment type customers, but also some of the most critical workloads that are dealing with financial securities, all with these low latency solutions.
It's true. You think about the finance one. We talked about matchmaking earlier. I mean, this is the ultimate like high-speed matchmaking when you're trying to find a buyer and a seller and match them up in incredibly short periods of time to make the market more efficient and to serve the economy. It's incredible. But I think it also highlights what we said earlier at the beginning of this, which is, originally low latency experiences were probably most compelling in things like social and gaming, but they're becoming critical across almost all business segments now. Like users themselves are used to things reacting quickly, but business processes themselves now have to move that quickly. And so, we see it starting in media, moving into finance. But I mean, this is really the way all apps are going to have to go as the market continues, I think.
Yeah, absolutely. I think that the future is definitely distributed, and getting more compute and content to as close to the users as possible is just where all applications are likely to go.
There's one thing I was going to mention too is when you think about these low latency experiences, right? So you've got this global backbone. We do connect to the internet because that's where a lot of other things come from. And one thing that's important to keep in mind, and one thing we spend a lot of time worrying about, is making that safe. Making sure that traffic that comes into the network is filtered, and making sure that it's not trying to disable your application, take it out of service. Because oddly enough, we do see situations where people will want to disrupt financial transactions or disrupt a game, oddly enough. And so we have our perimeter protection services, which sit and scan traffic as it's coming in, can understand if it looks like a threat, can limit it. And if you think about our network scale, we see so much of this activity that we're able to really rapidly pick it out and use that to protect. And so we provide not only the services to help you deliver the low latency experience, but also to kind of make sure that you're protected when you do connect.
Oh, wow. So when customers are using our services through edge computing, they're just getting this protection and they don't have to worry about these types of threats.
That's right. Yeah, we filter, we keep track of the nefarious actors, but also there's a bunch of services you can deploy if you want to implement even more custom security. Like say you have your own security department and you're thinking, hey, I really want to deliver this low latency experience, a little worried about all the connections this creates. You can use a firewall on your network, you can use a web application firewall, all the way out to one connected to your CloudFront distribution, and you can use those to provide additional security. So you can have it by default, and then you have all sorts of flexibility.
That's really impressive. So just kind of summarizing all of the different options that we have just on free compute. So I talked about AWS local zones, which bring fully AWS managed capacity into very close locations, typically in your local metro area. We talked about AWS outposts that allow you to bring AWS capacity into your data center. We have some other compute functionality available in CloudFront today. I wonder if you could talk a little bit about that.
Yeah, that's right. So as I mentioned earlier, there was this ticket scenario where a concert provider needed to validate that. So we have two types of compute you can run when a request is coming in and being fulfilled. So one of them is called CloudFront Functions, and you think about that as being able to process the request you're getting. Hey, I'd like to see this page. CloudFront Functions runs on that incredibly quickly and can modify that to do things like check for security, things like that. And then we have something else called Lambda at the edge, which is, if you're familiar with our serverless offerings, the Lambda function is slightly more rich than a CloudFront function, but not quite what you would expect from an outpost where you can run a full server.
I see.
It's a function that can run against the content you're going to return. Right, so you could say, hey, I want to customize this for you. Like in one case where people would do that would be to say, I want to do customized advertising for you or personalize this content for you. And so you can authenticate or authorize on the way in using the CloudFront function, and then you can customize the response using Lambda.
Wow, that's amazing. So you can run compute in the region, you can run it in our point of presences with CloudFront Functions and with Lambda at the edge. You can run it in your data center with AWS Outposts. And then for the really sort of extreme version of it, we also have the Snow family of offerings where if you're in a tactical environment or you're completely disconnected from the internet, you can actually get AWS that can fit in your backpack or you can throw in your trunk and provide functionality. And so we really do offer the full range of compute capabilities throughout our entire network, it seems.
That's right. Yeah, it's really just limited by customers' imagination and needs and what their customers are going to need.
Great. Awesome. Well, thanks a lot for chatting. I think this has been a super exciting discussion, and it's really, really exciting to see all the things that customers can build with all of these exciting capabilities.
Yeah, thanks. Thank you as well. And thanks for coming to Hybrid Cloud Day for now.